Okay, Assalamualaikum and good morning, everyone.
Waalaikumsalam, Ustaz.
All right, so today we are going to continue with example number 2 on how to sketch root locus, and then we will discuss the tutorial on sketching root locus or lecture 4D. All right, let's continue with example. Okay, so example number 2. So let's say you are given this forward transform and divided by s squared minus 4s plus 13. So given a unity feedback system, forward transfer function, so unity feedback. So when you have unity feedback, you don't have to um, determine the closed loop transfer function and then determine the poles. Okay, so you can determine the poles and zeros directly from GS. So the question asks you to sketch the root locus, find the j omega axis crossing, value of k at imaginary axis crossing, breaking point, and angle of departure from complex poles. Okay, so let's look at how to do this. So firstly, you can determine the poles and zero. So the poles is simply taking the denominator, make it equal 0, and find value of s. Okay, so you can use calculator to determine value of s. So you get 2 plus minus 3j and then zeros. So you take the numerator and then you get zeros equals s minus 2. So here you have complex poles. So when you have complex poles, meaning that you have to calculate the angle of departure. All right, so let's look at the example. So firstly, you can sketch the location of poles, which is located here. And then sketch the location of zeros. Okay, so we have 2 poles and 1 0. And then perhaps you can determine the location of root locus uh, depending on the odd number of poles and zeros. Okay, so if you can do it here. So you have minus 2 and sorry, bullet. And then you have minus 3j, 3j. Okay, so from here, from infinity to value 2 here, we don't have the root locus on real axis because there are no poles or zeros here. And then from 2 until minus 2, we have 2 poles, which is located here. So when we have 2 poles, it's an even number. So even number meaning that there will be no root locus on this real axis. And then from this minus 2 until negative infinity, we have 1, 2, and 3. So 2 poles and 1 zeros. So we have 3 things here. So we have odd number. So odd number meaning that we will have root locus on this real axis. Okay, so now we know that the location of root locus on the real axis, then we can get an idea how the root locus will look like. So here, the root locus, there will be a root locus here, and also here. Because on real axis from -2 until infinity. Okay, then the question asks you to determine the j omega axis crossing. So to determine this, you need to find the closed loop transfer function and then use the denominator and then use Radowitz criteria table. So here you have the forward transfer function and feedback transfer function. Then you find the closed loop transfer function. And then from here, you generate the Radowitz table. So we use S1, row S1 to find the value of K at a marginally stable system. And then we use this value of K, substitute into row S2. So 1S squared plus 13 plus 2K 2K times S naught. Okay. So use K equals 4. Substitute in here, you get S squared plus 13. 13 plus 8, 21 equals 0. Then you find the value of S. You get S equals plus minus J times 4.58. Okay, it should be somewhere here. At marginally stable. So we find the value of J omega axis crossing and the value of K. Now we need to find the breaking point. Okay, so why we have breaking point instead of breakout points is that we know that there's a pole here, there's a 0 here. So the pole must, the root locus must start from poles and then ends at 0. So one of the pole will go to the 0 here. So it can go here, for example, it can go here or anywhere. So meaning that if it goes, let's say if it goes like this, then it must have a breaking point, okay? Meaning that the root locus must break into the real axis. So that's why we have breaking point. Okay, so let's determine the breaking point. So using this formula, 1 over sigma minus 0 equals 1 over sigma minus pole. Okay, summation. So we get this. Then from here, you have 3j here. So you might, later when you do it by yourself, you might get confused how to simplify this. So I suggest you to simplify slow lah, okay? So I show you example for this part. So what you can do is you cross multiply, okay? Darat silang. So you get Okay, so you cross multiply, and then you will realize that on the numerator you get 2 sigma minus 4, because 3j minus 3j you can eliminate. And then on the denominator, this one is simply similar to this. So you can just write, sorry, minus 4 sigma plus 13. Okay, so you can cross multiply and then do it slowly, okay? Or because you are doing this exam later online, you can use Symbol Lab or MATLAB or whatever that you want. And then after that, when you simplify it, then you calculate for sigma. So sigma is minus 7. So minus 7 is the breaking point. Okay, so you can sketch minus 7 on the S-plane. Okay, so I forgot just now we have two poles. So we have two poles and 1, 0. So because we have 1, 0 only, then we need to add one more 0 at infinity to make sure that they are of the same values. Okay, so meaning that one of will go to infinity. And then after we determine the breaking point, then we need to determine the angle of departure, okay? Because the question asks you to determine angle of departure. So angle of departure are only for complex pole. So this is the formula for angle of departure. So to determine angle of departure, you need to determine the angle from this pole and this 0 to this pole here, okay, to this point of interest. So this angle will be 90 degree, and this angle is a theta that you need to calculate using trigonometry. So here, the example calculate using tangent minus 1, 3 over 4, minus 90 degree. So we don't have, so we have the angle of 0, which is tangent minus 1, 3 over 4. And angle of poles is negative, is 90 degree. Okay, so minus and minus 2k plus 1. So usually we take k equals 0, okay, or just minus 180. And then we end up with this value, negative 233.3. And then we can convert it into positive by by making 360 plus this at 360. So negative 203 from negative, from positive realizes, but clockwise. Okay, so make it positive so that you measure it this angle. Okay, so you get 360 minus 2 to 3.3, you get 1 to 6.7. Okay, so we have all of the information just now. Okay, so maybe I sketch here. So we have the poles here. Okay, so we have breakaway j omega axis crossing somewhere here. the question doesn't ask you to find asymptote, so it's okay. But usually, in exam, you will need to find everything. Okay. Okay, so we have all of the things here, and then we have break-in points here, -7. So we know that the poles must be the root locus must be symmetry about the real axis. So you cannot do like one go here and then one go here to infinity. So this is not symmetry. Okay, so you must make sure that you draw it symmetry on the real axis. So to make it symmetry, firstly you must make sure that the root locus pass this point 4.58 and -4.58 because it is the j omega axis crossing. And then you have the angle of departure, which is about 126.7. Okay, so the root locus will start something like this, and then cross the j omega axis. And then when it cross, it must break in this point here, breaking point. Okay, so both of the branches must break into the same point because you want to make sure it is symmetry. Okay. And then when it breaks into this real axis, then one of them will go to this 0, and then another branch will go to infinity. Okay, so that's why you get sort of like a circle shape. Okay, like in this blue color. Okay, so that's it for lecture 4D. Now let's look at tutorial. Okay, so there are 3 questions here. Okay, so sketch the root locus for the unity feedback system with forward transfer function g below by determining the following if they exist. Okay, so if these are exist, then you can determine. Okay, so let's look at the first transfer function. Okay, so you need to determine the asymptote, breakaway, breaking points, j omega axis crossing, the range of k, and then the angle of departure or arrival. Okay, so let's look at this question first. Okay, so firstly, you need to determine the poles and 0. So the poles are -2 and -4, and zeros are from this equation. So this is quadratic equation. You can solve it using a calculator. So you end up with 2 plus minus 4j. So it's a complex number, meaning that you have angle of arrival because it's a complex 0. So we have 2 poles and 2 zeros, which means that we don't have to add extra poles or 0 to make it equal because they are already equal in number. And from this, we know that there are 2 branches because we have 2 poles and 2 zeros. Then maybe we can sketch this on S-plane. So we have -2 -4, and then negative 4j here. J, so we have 0 here. Okay, so please make sure during your sketching later, you sketch it nicely, okay? Like a -2, -4, using cross to represent poles, using circle to represent 0, and put label, okay? So now we have this poles and 0 sketch, and then we can um, deduce, okay, deduce how the shape of the root locus will be. So we know that one of the branch will go from poles to 0, and another one will go from poles to 0 as well. Okay, because we have two poles and two zeros. And then we have two branches. Now we can determine on which location on the real axis the root locus will exist. Okay, so we can identify the location by calculate the number of poles and zeros. So from infinity to 2 here, there are no poles or 0. So there will be no root locus on the real axis. And then from this point, from 2 to -2, there are two zeros. So it's an even number. So there will be no root locus on this real axis. And then from -2 until -4, there are three things here. We have two zeros and one pole. So there are three things, meaning that there will be a root locus here. Okay, so there will be a root locus here. And lastly, from here to from -4 to infinity, there are four things, two poles and two zeros, meaning that there is no root locus on this real axis. So the root locus will exist only on here. Now we can somehow sketch the final shape. Get the idea how the root locus will look like. So the root locus will start here from poles, and then it will break somewhere in between here. Let's say it breaks here, and then after break, it will cross the j omega axis. Maybe cross here, depends, and then meet the 0. Okay, so the root locus will look something like similar to previous example. It will look like a circle. Okay, so what I drawn here is not a circle. Sebab saya tak reti melukis. Okay, so we leave it the sketching at the end, but we know the shape already. Okay, we get the idea about the shape. Now we can determine the asymptote. Okay, so asymptote. So the real axis intercept is sum of poles minus sum of 0 divided by number of pole minus number of 0. Okay, so from this equation, we have two poles and two zeros. So obviously, we will end up with some value divided by 2 minus 2. Okay, so infinity, because denominator becomes 0. Okay, so here we because you get this kind of calculation, it's actually meaning that there is no asymptote in this root locus. Okay, so there is no asymptote in this root locus, so we stop calculating. Okay, no asymptote. Okay, now we move on to calculating the breakaway and break-in points. So here we have a break-in point, breakaway points. Okay, because the root locus will break away from the from the real axis. Okay, so the formula is 1 over sum of 1 over minus 1 over sigma minus poles equals sum of 1 over sigma minus 0. Okay, so we have 1 over sigma plus 4 plus 1 over sigma plus 2 equals 1 over sigma minus 2 minus 4j, plus 1 over sigma minus 2 plus 4j. Okay, so since you have symbolet during exam, you can calculate this using symbolet. But if you don't have symbolet, then you can calculate manually. So you get and then try to simplify. Okay, so if your exam is face to face, you have to calculate this on your own lah. Okay, tak ada software. So because we are having online exam, so you can use Symbol Lab. So I'm lazy, I'm using Symbol Lab. Okay, so we get sigma equals minus 2.88, 5 point, and sketch this on the S-plane. Negative 2.88 and 5.28. Okay, so this point 5.28 is not the breakaway point because we know that there is no root locus after number 2 here. So this is just a dummy. So this is the actual breakaway point, negative 2.88. Okay, now we calculated the breakaway points. Then the question asks you to calculate the J omega axis crossing and the range of K. So for J omega axis crossing, we have to find the closed loop transfer function. Okay. So find TS equals GS divided by 1 plus HS GS. And then this GS is this S squared minus 4S plus 20. So we end up with okay, so if you don't know how to get this final closed loop transfer function, please calculate it slowly, okay? Saya kira ni sebab saya dah tahu macam mana nak kira. Jangan tanya macam mana dapat. Saya kira pakai otak. Okay, now we take the denominator. And then expand it before we can generate the Route-Hurwitz table. Okay, again, if you don't know how to get this, you can expand it slowly one by one and then rearrange, okay? Make sure you arrange in S squared, S, and S naught, okay? Ada urutan dia. And then after you rearrange this, then you can generate the Route-Hurwitz table. So we start with S squared. So here is K plus 1, 6 minus 4K. So here we get 8 plus 20K. So this is the Route-Hurwitz table. So we need to determine the K value first for marginally stable system. So we take S1. So from S1, 6 minus 4K equals 0. So K equals 3/2. And then use this on S2 to determine the J omega axis crossing. Okay, substitute K equals 3/2. And then find S. So S should be plus minus 2.37 J. Okay, so this is the J omega axis crossing. And then this is the K value, K at J omega axis crossing. Okay, so we answered this question. Question C. Now we need to answer question D, the range of K for stable system. Okay, so to find that, we use what we have learned from our Route-Hurwitz criteria lecture. Okay, so we take the first column. So in the first column, you make sure that there is no sign changes. Okay, so if there is sign changes, then the system is not stable. Okay, So from S2, so K plus 1 must be positive. So K must be bigger than minus 1. And then S1, we get this value just now. So 6 minus 4K bigger than 0. So we get K less than 3 over 2. And then lastly, S0. So we get K bigger than negative 2 over 5. Now you can buat garis nombor, okay? So the only range that all of the garis nombor intersect is this range. So K between minus 2.2 over 5 until 3 over 2 is the range for stable system. Okay. So this you have learned from Rutherford's criteria. It's just for you to refresh what you have learned. Okay. Now we have all of the things. Maybe we can sketch this J omega axis crossing on the S plane. Berapa tadi lupa? 2.37. So it's somewhere here. Okay, so let's say if I when you do the tutorial later, when if I did some mistake, please let me know. Okay. Okay. Now, lastly is finding the angle of departure. Okay, so angle of departure is on the sorry, angle of arrival on the complex poles. So we have complex poles, meaning that we have angle of arrival. So we don't have angle of departure because we don't have complex poles. We have only complex zero. Sorry, complex zero. So let's determine the angle of arrival. So we need to determine this angle. First is this one, theta z1. And then secondly is from this pole, theta p1. And then this angle, let's say theta p2. Okay, so let's determine theta z1. So theta z1 is simply 90 degree. Okay, so 90 degree. And then theta p1, you have to use tangent. So tangent this length divided by this length. So 4 over 4. So you get 45 degree. And then theta p2, also tangent minus 1. But now it's 4 over 6. Okay, this length. So it's 33.69 degree. So we get all of this, then we can use the formula from the slide. This one. So theta P, theta arrival equals theta P1 plus theta P2 minus theta Z1 plus 180. Okay, so use the value. So 45 plus 33.69 minus 90 plus 180. So you get 168.69 degree. So the angle is about here. Then we can maybe sketch the angle on the S-plane. Okay, so we have all of the information needed. Then we can sketch the final root locus. Okay, so the root locus will start from poles. So it will start here and here, and then break away from this point. And then it will cross this j omega axis, and then arrive at this um, 0 at this angle. Okay, so maybe something like this. Okay, lukisan yang buruk. Sepatutnya dia lebih smooth lah. Okay. Dia bentuk macam bulat sikit sebenarnya. Okay, so it should be something like this lah, macam tu. Bentuk dia. Tapi sebabkan graf ni lari-lari sikit, so dia macam tak berapa cantik. Okay. Okay, so you have two branches. Okay, going to the zeros. Okay. Any question before we move on to the next tutorial?
No, dah. Nak kena buat semula baru saya faham.
Nanti try buat balik, and then try compare lah. Okay. Okay, so I'll discuss the second question. So the third question, I leave it for you to do by yourself. Okay. I think I discussed the third question. The second question, I leave it to you. The third macam senang sikit. Okay, so let's look at the third question. Okay, so again, this is the transfer function. Okay, so we can first find the poles. So the poles, you look at denominator. So it's quadratic equation. So you can use calculator to solve the quadratic equation. So you get poles equals minus 3 plus minus 4j, and then zeros, it's simply minus 2 and minus 4, sorry, 2 and 4. 2, 4. So you have 2 poles and 2 zeros, meaning that you have 2 branches. Then you can sketch this on S-plane. Okay, and then we can determine on which portion of real axis there will be the root locus. Okay, so from here to infinity, there will be no root locus on the real axis. And then from here, from 2 to 4, you only have one pole here. So there's a root locus here. So you can sketch it. And then from minus 3 until 2, so you have 2 poles. So 2 poles meaning that it's an even number. There will be no root locus here. And from here until negative infinity, you have 2 poles and 2 0. So there will be no root locus on this real axis. So the root locus exists in between 2 and 4 here. Okay. And then we can determine the asymptote. So again, asymptote, because poles and zeros are the same amount, so no asymptote. Then we can determine the angle of the breakaway point. Okay, it's a breakaway because the roller coaster starts here and then breakaway meeting the zeros. So breakaway point. So sum of 1 over sigma minus poles equals sum of 1 over sigma minus 0. So 1 over sigma minus 2 plus 1 over sigma minus 4 equals 1 over sigma plus 3 minus 4j plus 1 over sigma plus 3 plus 4j. Okay, simplify. So you get sigma 2 sigma minus 6 times sigma squared plus 6s plus 25 equals 2 sigma plus 6 times sigma plus 8. Okay, and then you can use symbol app. So you get breakaway point at 2.889 and at minus 5.72. Okay, you can sketch this on the S-plane. So 2.89 is somewhere here. And then negative 5.7. So maybe here. Okay, so this point at the end here is not the breakaway point because we know that there is no root locus here. So only 2.89 is the breakaway point. Okay, so we have found the breakaway point. Now we can find the j omega axis crossing. So first, you need to find the closed loop transfer function. Okay, so you get and then we take the denominator and generate the route width table. Yes, expand and kumpulkan dia, kumpulkan the coefficient. Okay, so you can check later whether I did it correctly or not. Okay, maybe silap. Okay, and then you generate the route width table. So k plus 1 here, 6 minus 6k, 25 plus 8k, 0. So here is 25 plus 8k, 0. And then find the j omega axis crossing by first finding the value of k at marginally stable system. So use S1. So 6 minus 6k equals 0. So k equals 1. And then use this on S squared. So k plus 1, S squared plus 25 plus 8k equals 0. So to S squared plus 33. And then find the value of S. So S equals plus minus 4.06 J. So this is the J omega axis crossing. And this is the K at J omega axis crossing. And then you can find the range of K for stability by finding, by looking at the first column and make sure they are positive. So K plus 1 is bigger than 0. You end up K bigger than minus 1. And then second row, so K less than 1. And lastly, you get K bigger than minus 25 over 8. So it's about 3.5. 0.125. And then buat garis nombor. So the range of K is when all of the garis nombor intersect. So it's here. So range of K is of K for stability is K from -1 until 1. Okay, then we can put this value on the S-plane. So it's somewhere here. Minus 4.06. 4.06. Okay, now lastly, we need to find the angle of arrival. Okay, because we have complex zero, then we only have angle of arrival. Okay, so let's do it. Okay, so you need to find this angle. Let's say theta Z1. And then this angle, theta P1. And lastly, this theta P2. So theta Z1 is 90 degree. Theta P1, you have to use trigonometry. So here I will use tangent -1. No, 180 minus tangent -1 of this angle. So that will be 4/5. So you get 141.3 and a theta P2. So similar. So it's a 4 over this length 7. So you get 150.3. So then the angle of arrival is theta P1 plus theta P2 minus theta Z1 plus 180. So you get 381.6 degree. So dia buat one circle already. So just minus 360. So it's about 21.6 degree. So the angle is something about this, like this. And then from here, you can sketch the angle on the S-plane. Okay, so we get all of the information. Now we can sketch the root locus. Okay, so the root locus will start here and then break away from this point and then intersect at this value here, j omega axis. And then coming into the 0 at this angle. Okay, so bentuk dia macam bulat tapi sebab lukisan saya buruk. Okay, so that's it for today. We will discuss question 2 maybe on Wednesday, inshallah, or maybe next time. So that's it. Any question before we end our lecture?
Yeah, Doctor.
Okay, so I want you to try it later. And then your project part 3, root locus, the due date is next week, week 13, next week, Sunday, okay, Sunday midnight. So you can start exploring that. So for part 3, I suggest you to start with MATLAB, using MATLAB first. Try to sketch the root locus using MATLAB. And then for the manual calculation, you calculate and then compare your results with MATLAB, okay? So when you calculate using manual, you might calculate it wrongly, okay? So to know whether you calculate it correct or not, compare your calculation with MATLAB, okay? So they must be 100% the same, okay? Tak ada error ke tak ada, okay? MATLAB dengan manual calculation for root locus will be 100% equal, okay? I think that's it. That's it for today's lecture. If you have any question, feel free to WhatsApp me. Okay, so that's it. Thank you very much. Assalamualaikum. Goodbye.
Yeah, thank you.
Thank you.
Thank you,
Thank you,
Doctor.
Doctor. Sir. Thank you.
Thank you.
Thank you, Doctor.
Thanks.